Jiyoung Choi, in Japanese, Chejiyoung, Cheju no Che desu. So,
Cheju is my Japanese name.
actually last year, I made a presentation, but because of COVID, I just couldn't make it, and last minute I have to ask our CEO to present. So this year, I'm here, really glad to be here to present my slides. So today I will talk about two quantum computing landscapes. One is network and another one is technology, so that you can better network in this kind of conference. And also you can find maybe your next business opportunities with quantum computing related technology. For those who doesn't know about VALUENEX, VALUENEX is a big data predictive analytics company specialized in data visualization. And we have our proprietary algorithms for the visualization so that we can help our clients to build data-driven strategy and decision making. Also, our mission is creating knowledge and insights from the data and information so that our clients can better build the strategy, and we serve everyone who seeks knowledge and insight through our data visualization. So, like I said, I will show you two quantum computing landscapes. One is network, and another one is technology. So the first, network. So since pandemic, everything can be literally accessed through online, right? I'm sure that this conference will be recorded and shared later. So the question is, why are we here, in person? My guess is not only for knowledge, but also networking. It is very important. You meet people in person and build community. But the problem is, if you just walk randomly, just networking, you'll be all over the places, right? And even if you meet 25,000 people in your life, still there will be white space people who you never know and never met, doesn't know their existence. So what we can do with this kind of situation? So to build a strong network and network efficiently, I want to ask these questions. First, how the landscape of key players in quantum computing look like. Where am I? Where is my company? Or where am I? And third, how can I navigate myself in the network of these key players? So I use this database called Crunchbase, the startup database, and used search query quantum computing in the business description of the company, and gathered 400 companies. And there are 1,287 companies, founders, and investors. So for example, QCware, Matt Johnson and Randy is the co-founder of QCware. And I'm sure Randy is connected to their investors. And one of the investors is Archemist Accelerator. And Archemist Accelerator also invests in Rigetti Computing. So I guess that Randy is connected to Rigetti through those common investors. So that's the concept of network, the network analysis. So this is a visualization of all those networks, 1,287 companies, founders, and investors. And interestingly, you can see the core group, like inner circle and outer circle. So you can see the core group inside, and you can zoom in to see clearly how people are connected. Oh, by the way, those blue dots are the company's founders and investors, and the distance will represent the relationship, how strong their relationships are through the working and also investment relationships. So if you zoom in, you can see those players. So I highlighted investors in quantum computing who invest in quantum computing more than 2 companies. So these are the players, the key players in terms of investors in quantum computing. And I look into headquarters, and interestingly, there's a division between US, so on the right side, mainly US, Israel, Canada, UK, and the left side is EU. So maybe those two groups can be better connected through some investors, maybe closer to the borderline, which can be the Creative Destruction Lab, CDL, or Innovate UK, or Quantum Nation in France, maybe those investors can be the bridge between those two groups, the US side and EU side. Also, by the way, do you know Bacon's law? Anyone? So Kevin Bacon, the famous American actor, so there's a game called Bacon's Law, 6 Degrees of Kevin Bacon. So the game is like this. So you find the actor, randomly choose the actor, and then you connect the actors through the film, so that you connect. So eventually, the goal is to get to Kevin Bacon in 6 steps. So that's the rule of the game. So in this case, far left hand, there's a investor CITIC, Swiss ICT Investor Club, might be connected to far right hand, Archimedes Accelerator, maybe in 6 steps. So like 1, 2, 3, 4, 5, 6. Like the Bacon's law, the 6 degrees of Kevin Bacon. So this kind of networking, the network map can guide you how to get there through this personal introduction, so that you can be more efficient in networking. Also, we can zoom in further to see a clear picture of who are the players, the startups near those investors. So I zoom in this EU side investors and startups. So for example, Pascal, I'm sure they're here in this conference, and Well Inc., they're very closely related, connected through this common investor, Runa Capital and European Innovation Council. And maybe Pascal and Well Inc. can build this community through those common investors and maybe all the players. So this can help them to better navigate themselves and build a community. Similarly, US side, I just zoom in this areas near this Creative Destruction Lab. So for example, there's a company called 0 Point Motion and Orange Quantum System. Maybe they can get to Creative Destruction Lab through Orca and others. So maybe this can be useful, like a Google map. You want to know where you are, and you might want to know how to get to your the goal, the destination. And I was wondering, because this is Q2B Tokyo, right? Okay, where are the Japanese players, right? So I identified those Japanese players in the upper side and the bottom side. Unfortunately, the Japanese players are outskirts, not inside this core group. So first, I want to show you this upper side groups. So similarly, you can zoom in to see all the Japanese players in this group. And there are 2 core startups in this group. So one is Kinesis, which is also the Q2B's organizer. And another one is Preferred Networks. And the connection is Mitsubishi UFJ Capital. They connect those to startups. So if you're interested in building the community, maybe these are the core players in Japan. Also, I was wondering, the bottom side, it's a smaller group, but this bottom side consists of the companies like Mizuho, ANA, and Tokyo Tsusho. So I don't know why Japanese groups are divided like this too, but it will be interesting to see in the future this collision or integration of US side, EU side, and Japan side in the future in terms of investment and these working relationships. So to summarize this network, how the landscape of key players in quantum computing look like, there are clear division between US and EU side, but maybe these players like Creative Destruction Lab, CDL, or Innovate UK, or Quantum Nation can be the bridge between those 2 groups. And also, where am I? Of course, it depends on who you are, but it would be nice to kind of see where you are and also think about your objective, where do you want to go, how to get there. But maybe this kind of map can give you some guidance. Like Bacon's law, you want to know how to get there in a more efficient way, like 6 steps. You don't want to have too many steps, right? So this can be interesting to see how you can leverage those relationships with the map. So next one, technology. So to understand the quantum computing technologies, you also might want to ask, okay, what is the trend and opportunities in quantum computing? And what is the focus area of each key players? And how the competition in quantum computing look like? So to understand that, similarly last year, I used quantum computing. I gathered quantum computing related patents from USPTO, US Patent Office, from 2001 to 2023. So update is really this recent last year and this year's patent, which is around 4,200 patent applications, and which is growing. So this is a landscape. I know there are a lot of colors, but this will represent the density of those technology, the patent documents. So similar to the network analysis, the distance will represent the similarities of the documents, in this case, the patent documents, the technologies, and the density will represent the, how much focus there has been in this specific area. So I want to start from the right side. So right side is superconducting qubits. Superconducting qubits area, and you can also divide inside the superconducting qubits with the fabrication of superconducting integrated circuits and electrodes, resonators, and method of coupling qubits and quantum processor cell, and so on. And another type is, of course, ion traps and topological qubits, quantum dots, and also quantum annealing, which is on the more left side of this map. Also, there are other parts that are very important, like error corrections, magic gate distillation, analog processor for computation, and noise reductions, hybrid quantum systems, quantum circuit generation and design, and in terms of application areas, simulations, optimizations, and machine learning. I know there are a lot of labels, so I simplified this map. So basically, right side is hardware, left side is software, and maybe application on the left side. But the point is there's gap in between. Still, gap is there. Last year, gap was there. This year, still the gap was there. Gap is there between hardware and software of this quantum computing. And the trend line, so the black line, we call trend line, which will give you how this industry has been shifted. And it seems like the focus is still, yes, this line, is from the hardware towards the software. And actually, this transition is accelerated into 2023. So when I only filter 2023 patents, you can see this clear focus on software, algorithm, and application. Actually, this is very interesting. I thought that there are more hardware development still going on, but this year, a lot of focus is really mainly on the software side. Also, the key players. So what IBM is doing, of course, they do the superconducting qubits, especially the resonator, and also left side quantum circuit generation and calibration. So those are kind of their main focus. And D-Wave, still quantum annealing, and also within superconducting qubits, method of coupling qubits. Those are the high density area. Microsoft is interesting because they're working on topological qubits, but it's kind of hard to see the connections towards the software side. In software, they do decoders and data compression. And Google, in superconducting qubits, their focus was on this flux qubits, and they also work a lot on the qubit calibration area. So to combine all those key players, 5 key players, IBM, D-Wave, Microsoft, Google, Intel. When we look into all those players, activities, there are 2 main competitive areas. So hardware side, superconductor fabrication and engineering is one of the hottest area because everyone is working on it. More software side, definitely the hybrid, the quantum classical computing system is one of their, everyone's focus in this case. Also, we are the Japanese, right? This is Q2B Tokyo. So I highlighted 5 Japanese players, Fujitsu, Toshiba, Hitachi, Japan Science and Technology Agency, and NTT. As you can see, a lot of focus on hardware, some focus on software side, still the gap. There are a lot of void in the middle and also software side. And I was wondering what's on the left side. And actually, it's related to the optimization method. So within the software side, maybe the Japanese players are more on the optimizations. Okay. So to summarize this technology quantum computing landscape, so what is the trend and opportunities in quantum computing? So overall trend is still there. It's moving from quantum computing hardware to software and application areas, and significantly accelerating in 2023. I don't know why, but it's really moving towards that direction. But there's still a gap in between those hardware and software, which is white space. So maybe there can be some opportunities to develop these connections. The second, what is the focus area of each company, especially those key players? So IBM, their focus is in quantum circuit generation, calibration, and D-Wave, the method of coupling qubits, Microsoft, decoder and data compression, Google, flux qubit and qubit calibration. And how the competition in quantum computing look like. So there are 2 competitive areas. So one in hardware, which is superconducting conductor fabrication and engineering. And in software side, more on this hybrid quantum classical computer related areas. So thank you so much for coming to my sessions. And I show you a lot of maths, 2 maths mainly, so network analysis and this technology landscape. So if you're interested in knowing more about to really understand where you are, where your companies are, please feel free to reach out to me. Thank you so much.
Thank you, Jiyoung. Pardon me. And our next speaker of today.
Time for...
Oh, did you have time for questions?
Yes, yeah.
Do we have time for a question, and I see a hand raised already. My apologies.
Yeah.
Hi, yes. I was wondering if this radar can be extended to see kind of like beyond just people and companies. Like if I, as a potentially someone who works in a biopharma space, I have hundreds of thousands of patients. Is it possible to look into the kinds of like symptoms potentially if I were to market a certain drug? Like, is that possible for other applications?
Yes, so we can visualize text data. So maybe those symptoms data is stored in text format. Maybe we can visualize those text documents to see the relationship with the symptoms and maybe what caused the symptoms based on the distance of those text documents. In terms of relationship to network, I'm not sure what kind of data is really for those network analysis. But actually, when I look at the Bacon's law, actually, I was thinking, oh, maybe we can scrape some data from Netflix or Rotten Tomato to gather those actors' data to see those actors' networks. So that was one of the ideas. So it's really not just this kind of startup data. We can visualize a lot of network, even I don't know, the inventors' network, researchers' network. So we can visualize a lot of those people to understand how the relationship is created. Yeah.